Welcome. This is part 16 about the Olshammar Engine. This is about computer simulations done at Chalmers University of Technology, Gothenburg, Sweden in the fall of 2025. It is a simulation-based approach of a 5-stroke turbocharged engine using Siemens Amesim, a different software than used before. And it's a master thesis of 2 students, Wilhelm Hansson and Fredrik Åberg, and their supervisor examiner was Professor Petter Dallander. The research questions they asked was: how does the Olshammar engine perform compared to a 4-stroke engine of same characteristics? How does the exhaust cylinder contribute in terms of overall performance and why? What is the reason for having a side port and what effect does it have on the engine's overall performance? What are the advantages and disadvantages of Siemens Amesim in terms of modeling internal combustion engines? Should Chalmers consider the option of replacing GT Power with Amesim in the internal combustion engine course? I will not address the last 2 questions about Siemens Amesim compared to GT Power, but the results we received were quite similar, so I'm quite satisfied. And we made simulations on a baseline engine, a gasoline engine, spark ignition, 1 liter, 2 cylinders, and the Olshammar engine with the exhaust cylinder, and the Olshammar engine with exhaust cylinder plus side port. So these are similar to the previous simulations done in GT Power by KTH and FEV. There are some differences in these simulations. If we look at these results, we see that the torque in red curves is a fixed line for the baseline engine and a dotted line for the Olshammar engine, and they are perfectly overlapping because they decided to use a turbo and then adjust the turbo pressure so that we will get as much torque and power for each RPM for all the different engines. The brake-specific fuel consumption is in green, and here we can see that the dotted line is a little bit lower in the middle, but a little bit higher at the highest RPMs. And to the left is the one without the side port, and to the right is the one with side port. And the performance with side port is a little bit better overall. And here are bar charts of the same, and we can see that in the mid-range RPMs we have fuel savings for the Olshammar engine. And to the left we see the version without side port, and we see that at 6,000 RPMs the fuel consumption is 5% higher than the baseline, but if we have the side port it's only 3% more than the baseline. And if we look at 3,000 RPMs we see that the savings are more than 4% with side port, but without side port it's 3.5%. So the side port is giving some effect here. And here we see that the influence of fuel consumption with side port is the most at the higher RPMs. And the power contribution from the combustion cylinders compared to the exhaust cylinder contribution. We can see here that the version with side port at 1000 RPMs and 6000 RPMs, the exhaust cylinder does not contribute positively. It's a negative value. But for all other RPMs, it's a positive value, and that's where we get the fuel savings. Previous simulations at KTH using the GT Power software instead. This is for a similar engine, It's a 2-cylinder engine with bore and stroke similar size, and 1 liter. It's a petrol engine, spark ignition. But here we use the turbine simple and compressor simple models used from the template library in GT-Suite instead of the turbo maps used by the Amesim simulations. And for these simulations we could set constant pressure for the turbo. So for the lowest version we had the 1.5 bar absolute boost for all RPMs, and then we tested for 2.5 bar all RPMs and 3.5 bar all RPMs. And if we compare that to the Chalmers Amesim simulation, the baseline engine only had 1.15 bar absolute boost at 1000 RPMs, and at 6000 RPMs it was 1.95. And if we look at the Olshammar without side port, and yeah, we had 2 bars absolute pressure at 6000 RPMs, which indicates that you needed higher boost to produce the same power for that one. But at the mid-range RPMs, like 3000, 4000 RPMs, we can see that we needed lower boost to produce the same power with the Olshammar engine versions. So the conclusion is that the results from the Amesim and GT Power simulations, they show both positive results for the mid-range RPMs, and for low boost pressure like 1.5 boost, the Amesim simulations actually gave us better results. But the conclusion is also that to get really good results we need higher boost, and it could be good for the future to test this engine on larger engines that can take higher boost, and possibly different fuels where natural gas seems to be a promising alternative. If you like more information, you can go to the olshammar.com website, or you can write me at mats@olshammar.se. Note that the Amesim simulation data is available also, but it's about 1 gigabyte of data, so you can need to contact me so we can see how to transfer that if you need it. Thank you.